Hello everyone, we are Hibikino-Musashi at home. We talk about our object recognition system using flexible tactile sensors and a low-power reservoir chip. This is a demonstration of the tidy up task. Our robot can tidy up one object per minute. We scored high on this task and won first place at the RoboCup Japan Open in December 2020. Although our robot can do tidy up tasks at high speed, it often misrecognizes objects and puts them in the wrong places. In this case, the rabbit toy and the hedgehog toy are recognized as the same object. This is caused due to similarities in their appearances and surrounding environments. To solve this problem, we use tactile information instead of images. In addition, the computation of conventional neural networks for object recognition requires a significant amount of power, and thus it can reduce the uptime of the robot. By using an analog chip, power consumption can be reduced. We use this flexible tactile sensor. This sensor is made of silicon rubber, liquid metal, and a coil printed on a circuit board. When a force is applied to the sensor, the liquid metal flows in the sensor, and the inductance of the coils changes. We can get the hardness of the object by observing the changes in the inductance of the coils. When we touch the sensor with our finger, the sensor value changes as shown in the graph on the screen. We installed the sensor on a robot hand for object recognition by a tactile sensor. Let's grasp an aluminum can with this sensor. The sensor value goes down when grasping and it returns to the original value when releasing. Next, let's grasp a hedgehog toy. We can get a different sensor value. By comparing the observed values, we can distinguish these two materials. Since this sensor is made of soft materials that can be stretched and bent, it can reduce the risks of damaging objects or injuring people. Next, we talk about an object recognition system using the flexible tactile sensor and reservoir computing. Reservoir computing is a type of recurrent neural network that processes time series data. The computation cost of conventional recurrent neural networks is high since it updates all of the weights using backpropagation through time. On the contrary, the computational cost of reservoir computing is lower because it only updates the weights between the reservoir layer and the output layer. We have developed an integrated circuit for this model. This is an enlarged image of the chip for the reservoir computing. The chip runs at an ultra-low power of 117 microwatts, which is 1/60,000th of the power consumption of the most advanced low-power GPUs. It can perform object recognition without affecting the robot's uptime. In this system, the sensor data obtained from the flexible tactile sensor is processed by the reservoir chip, and the robot's behavior is determined according to the results. As we have seen in the first part of this video, the robot with a conventional object detection system misrecognized two objects, the rabbit toy and the hedgehog toy. In this demonstration, the robot classifies two objects by tactile information. First, the robot contacts the rabbit toy to get sensor data, then sends it to the reservoir chip, which is connected by a cable. The reservoir chip processes sensor data, then sends back the result to the robot. The robot stores the toy to the predetermined place according to the result from the reservoir chip. In this case, the robot stores the rabbit toy in the drawer. Next, the hedgehog toy is placed on the table. Again, the robot contacts the hedgehog toy to get sensor data, then sends it to the reservoir chip. The reservoir chip processes sensor data, then sends back the result to the robot. In the case of the hedgehog toy, the robot stores the toy to the predetermined place, box B, according to the result from the reservoir chip. In this method, the robot could recognize two toys without using information from the image. We proposed an object recognition system using the flexible tactile sensor. By using the proposed sensor, the robot recognized two objects from the tactile information with ultra-low power. We will develop a more advanced recognition system by combining tactile information with images.